Okay, question number one. Okay, this question is for 7 marks. So what I have done is I considered for 7 minutes. Let me start the timer. Right. So state Newton's universal law of gravitation. So as you know, it's for 3 marks. So what you need to do is first is statement. What is the statement? Force between 2 point masses is directly proportional to product of the masses and inversely proportional to square of the distance between the two, and you need to put 2 dots over here and say this is mass m1, mass m2, this is the distance over here. Okay, so this is the first thing that you need to write. It's force. Okay, this is the first point. One more point, the second point is that this force is attractive. You need to mention this also. And then the third point which you need to mention is that you can write F equal to G m1 m2 divided by d square, where G is the universal gravitational constant. Okay, so if you mention all these three, you will get 3 marks. Okay, don't just mention F equal to m1 m2 by d square. You will not get mark over there. Okay, you need to mention very clearly this, because when you say that, when we see that it's something like state, command term is state, but still you are getting 3 marks, that's what you are expected to do. Okay, next, deduce that the gravitational fields and G at the surface of a spherical planet of uniform density d is given by G equal to gm by r square, where m is the mass of the planet, r is the radius, G is a gravitational constant. You can assume that the spherical objects of uniform density act as point masses. Okay, this is for 2 marks. So here the question is simple. So what you need to do is you need to say that the force between any two objects is given by G m. What is this? G m into capital M divided by r square. When is it so? Consider a spherical planet and consider an object of mass m. Okay, and the radius of the planet is r and the mass of this planet is m. Then the force that attracts this mass towards it is a gravitational force, which is given by G m capital M divided by r square. You mentioned this. Then by Newton's second law, since it's an unbalanced force, you can now write F is equal to m into a. So as a result of it, equating these two, I can now write m into a is equal to G m m divided by r square. This small m and this small m goes away, which means a is equal to capital G m divided by r square. Now what is this? This is your acceleration due to gravity, and this acceleration due to gravity is denoted by the letter G, and hence the letter G is equal to capital G m divided by r square. Okay, you can mention so far, and thus we have arrived at an expression here. Okay, so this will award you 2 marks. The first mark will go for representing these equations. The second mark will go for arriving at this particular equation using this methodology. Okay, so here why did you use this? You use Newton's law of motion. Okay, now next, the gravitational field strength to the surface of Mars. See here, gravitational field strength to the surface of Mars is related to the gravitational field strength to the surface of Earth by given over here. I'll do one thing, I'll put my picture somewhere over here so that it doesn't block anything to me, right? Because that side of it is not being used much. Put it over there. So now gravitational field strength is given by Gm equal to 0.38 times Ge, and the radius of Mars is also given by so much. Determine the mass of Mars in terms of mass of Earth. Okay, now what we need to do is, so we know Gm, we know the value of G is given by Gm divided by r square. Now let us write down here. I will write this as capital G, capital mass of the Mars divided by Rm square is equal to 0.38 times Ge. What is Ge? Gme divided by Re square. This Re, E is suffix here, Re square. Now it is already known Rm is equal to 0.53 times Re. Let me substitute it for this. So which means, let me just scroll it upwards. So I have Gmm divided by, what is Rm here? Rm is 0.53 times Re. 0.53 times Re whole square is equal to 0.38 times Gme divided by Re square. Now what do we have here? See, you see this G cancels on both the sides, and I have mm divided by 0.53 square into Re square, is equal to 0.38 into me divided by re square. Re square also goes away. You want the mass of the Mars in terms of Earth. So therefore, let me simplify this. I can now write mass of the Mars is equal to 0.38 into 0.53 square into mass of the Earth. Now let us use my calculator to find out what is this value over here. Okay, I have to start my calculator. So CALC. Right, I'm using a system-based calculator. You can use it in your own. So I have 0.38 star 0.53 square. Where is square here? Square is here. Is equal to 0.1067. So the answer here is 0.1067 times mass of Earth, or I can write this as 0.11 times mass of the Earth. So this is the final answer. Okay. Then let us move on to the next problem. Right. Thank you. We have finished this within 6 minutes.